previous video, I made an alloy of bismuth, indium, and tin. It's called Fields metal. And I wanted to do some experimentation and see how it compares to solder, because it is a very low melting temperature alloy. First thing I'm going to do is I'm going to see how well it adheres to copper. This is normal solder first. I'm going to do that on this side. I'm going to paint on some flux here. And I'm going to use a cheap soldering iron because I don't know if the Fields metal is going to ruin it, but here's some normal solder. Okay. So it clearly wicks onto the copper and wets it. I'm going to use some flux on the other side of the penny. And clean off my soldering iron. And I'm going to grab a piece of my Fields metal. Nice chunk here. Alright, here's my piece of Fields metal. I'm going to heat the penny. Oh, it's already got solder on it, but let's see what happens anyway. Oof. So that's interesting. It does wet the copper, but the thing is, the solder has already turned solid, but as you might be able to see, the Fields metal has actually remained quite liquid, and it's been sitting there for a good, 10 seconds, 15 seconds at this point. The heat in this penny is pretty much not going anywhere very quickly. It has to radiate it out into the air mostly. But I can touch it for quite a while, and yet still, let's just even smear it a bit. Well, you can see my fingerprint. So this reminds me of a product called Chip Quik, which is a metal fusible alloy that lets you very easily remove electronic components. I think I'm going to try removing some surface mount components using Fields metal. Actually, before I go to removing a surface mount component, I decided to try something else. So I have here a fresh penny with flux already on it, and I'm going to put a little piece of Fields metal on here like that. And I am actually just going to heat it up with a normal butane lighter. And there you go. So that is it. Yeah, that's pretty well adhered there. It's still a little bit liquid. If I touch it with my finger, I can actually spread it out with my finger and no issue there. Look at that. Ooh, I could make a silver penny. Well, a Fields penny, I guess. But that looks pretty cool. Oh, it's still liquid. Look at that. That is a metal that I'm just smearing with my finger. Alright, now it's pretty solid. So I'd be interested to find out if this ever eats into the penny or degrades it in any way. I guess I'll find out over time. I'll let these pennies sit around for a while. Alright, let's move on. Alright, so this is an old just scrap board that I have that I think it was like a DVR or something like that. So I'm going to see how well I can use Fields metal to remove some of these components. So now on the other side of the board I have these two large surface mount chips, which are usually the most challenging type to remove because they have pins on all four sides. Some of these chips, like these, they're a lot easier if you just put a big blob of solder on both sides and then you keep heating one side and then the other and the other and the other. Doing that is possible with these. Much more difficult with these. You can see I already removed it and then put it back on. This one I already have with a bunch of solder. This is just normal solder. And I thought I would first demonstrate how hard it can be to remove these with just normal solder. I'm going to put a bit more flux on these. Actually, lots of flux. Okay. And there are other tools that are better for this, but the point here is that I want to use just a soldering iron. So yet to feel this thing even budge upward. Pulling up as hard as I can. Can't even get the tweezers under there really, but I am managing to put some upward pressure on it. And obviously I don't care about this board, but what if I did? What if I cared about the board? What if I cared about the chip? The whole point would be to successfully remove this without damaging it. I guess once I get this thing under there, I could just pull up like this. Okay, it's kind of getting under there. Oh, man. I thought that wasn't going to happen. All right. I actually got the chip off. I'm going to be honest, I didn't think I could do that. I'm usually not very good at this. There's a couple of pins bent a little bit. The pads, let me see. Whoa, let's actually see about getting some of this out of the way. Yeah. So I see ripped up pads here, two here. There's one over here, I think. Is that what that is? I think that's what that is. There's 4 up here. So this chip, obviously I already attempted to remove it by normal means with just solder and a soldering iron, and then I put it back on. And it looks like a mess, because it is. But I am going to do the same thing, but I'm going to use solder and Fields metal to see if the process is a bit easier. Okay, let's flux it up. I'm actually using a different type of flux than I originally used on this, so we're mixing fluxes now. This is not very scientific. Introducing as many variables as possible. Science. I should say even uncontrolled variables. Yes, introducing as many uncontrolled variables as possible. Science. Terrible science. Alright, so first, let's put a bunch of solder on it. Now, I'm going to introduce a little nugget of Fields metal into each of these. Okay, one. Let's see, how about a nice big chunk for the sides. Alright. So now, very simply, going to pick a good corner to lift from. And put my... Oh my gosh, this is exciting. I don't know why I'm so excited about this. Try and get my tweezers under there. Okay. That was already way easier. Oh my gosh. Yeah, baby. That was so easy. And look at that. They're still molten. I can still just kind of brush them off. Now, I'm pretty sure I had already damaged some I believe I damaged one before. Sorry, my solder iron is really dirty, but I don't want to clean it in my brass mesh. Yeah. So there's one. I'm pretty sure that's the one that I already broke from previously removing it and putting it back on. Gosh, this is so scientific. Look, hey, look at the damage that I probably already did before. Alright, so what are the conclusions about Fields metal? Well, it wets copper. It works well with solder flux. It significantly lowers the melting temperature of solder. It allows you to easily remove a surface mount chip that's very difficult to remove, and through-hole components. It is known to be corrosive to aluminum. It may or may not be corrosive to copper. I have yet to find that out. It's also possible that any solder joints that are contaminated with Fields metal are going to be weaker. You generally don't want this kind of frosted look on your solder. And lastly, I am not that skilled at soldering, so my ability to solder this device back on is not an indication of the effectiveness of Fields metal, but god damn it.